Okay, for today, to warm up, we want to look at a piecewise function. And what that is it's a function comprised of parts of other functions, two or more other functions. It's like the Frankenstein's monster of function, right? A little bit of this, a little bit of that, put it together, get something new. So with this is the function over here. It's called f of x is its name. There's just a little brace there. And the first line says x squared, so that's how you get the output, right? The output is x squared when x is less than or equal to 2. Okay. The output is 3x plus 1 when 2 is less than x is less than or equal to 5. Okay, you have different rules based on where the x value lies. And then the output is just 5 when x is greater than 5. Okay, so that's what we're doing there. So it's a little bit strange is that if I go to evaluate one of these pieces, I need to first figure out which of these three domains it hits. Right? Sometimes you'll even see these in interval notation. Here we see them in inequalities. They're either way is fine. So with this, to do f of 0, I want to look, and 0 has to fit into one of these three rules. Right? And 0 is less than or equal to 2, so we're going to use the top rule. So that means f of 0 is going to be 0 squared, which is going to be 0. That's our first answer. That means on this piecewise function, we would have the ordered pair 0, 0, right? A function also indicates an ordered pair. For the next one, f of 2, these are usually the ones that can be tricky because here we see a 2 here in this interval or this inequality and also in this one, but that's where we have to really watch where there's an equal. Right? So we know that 2 is less than or equal to 2. It makes this first inequality true. Where the second inequality, 2 is not less than 2. It would fail in this one. So again, we use the top rule. We get 2 squared, and that gives us 4. Good?
Yeah.
Okay. For f of 4, again, we look over here. Well, 4 fits between 2 and 5, doesn't it? So we use the middle rule. So 3 times 4 plus 1 would give us 13. So the point 4, 13 is on our graph of this function. F of 5, again, it's on the dividing line, right? But it would fall in this one because 5 is less than or equal to 5. So we do that, and 3 times 5 plus 1, that gives us 16. Now that, because it's at the end point, there's a good chance that's going to be an end point on the graph, and we'll talk more about graphing these next week. And lastly, we have f of 6, and that falls in the bottom inequality. Right, 6 is greater than 5. And this is just a constant. People tend to get confused by those, but it just means that any number I plug into this function that's bigger than 5, the answer, the output is always 5. Right? It's just a horizontal line. So in terms of the graph, that would be a horizontal line. So that would be 5. Okay? That's just an introduction of how to evaluate a piecewise function, given a piecewise function. Next week we'll come back and we'll look at how to graph those. Right? We want to make a graph of this, and it's not much different. Just a couple of things to watch out for, and sometimes open circles and closed circles can be a little confusing. So there we go.